My name is Louise Frenck, and I'm a postdoc. I've been working on this project since about 10 months now. Everything we do is inside the glove box because lithium metal and lithium salt are sensitive to air moisture. I'm working on lithium metal polymer battery, currently on understanding how lithium dendrites are growing into the battery. And it's a very important problem because it can lead to shorts on the battery. And so I'm working currently on understanding the thermodynamic factor which can affect the lithium dendritic growth. And so I'm currently studying the salt concentration and the pressure, temperature, and I have the opportunity to work with the ALS inside the synchrotron in order to do tomography, which is a technique to image the electrode and electrolyte interface. So it's very interesting. So here is our wet box where we can make our electrolytes. So electrolytes are made of polymer, lithium salt, and solvents. I think we still need to understand lithium metal. It's a material which has been studied since 40 years, but still it's not completely understood. So I think it's very nice to be able to work with this technology and to understand fundamentally what's going on and in order to mitigate those bad sides. Using solvent, polymer, and lithium salt, you let them steer for a certain amount of time to be sure that all the lithium salt is well dissolved inside the solvent. And after, you can cast the membrane on the top of the casting plate. You let it dry for at least 1 night. So this is the first dry part. And after, we will bring this membrane inside another glove box, which is called the dry glove box. So we use this antechamber in order to bring something from outside to inside or inside to outside. Well, I think EBI is a nice institute in order to mitigate climate change, and I think it's kind of very important right now. And I'm happy to be part of this institute, and I think it's very important for our planet to get more scientists on climate change and the way to have some solutions. When we have our membrane, we can bring it inside this chamber where we have a heater, and so we will cool under vacuum and heat any traces of solvent left to be sure that we have a very dry membrane. And after, we can take this one inside the glove box, and we can punch it and use it with lithium metal electrodes and cathodes, depends on what you want to do, or aluminium in order to do ionic conductivity, which is one characteristic experiment that we do. In this case, we know that in some years we won't have more fossil fuel energy. So we need to find solutions now. It's not in 10 years that we will have okay, we don't have more, what are we going to do? So we need to find a solution now. We need to find new technologies, and so that's why I think my work and the work of the other scientists in the battery field is very important. And